Ladies and gentlemen, welcome to another webinar from SD Times. Today we have Steve McConnell speaking about managing technical debt. Steve is the CEO and Chief Software Engineer at Construx and also a famous author. You may have read his most recent work, Software Estimation, Demystifying the Black Art. And today we'll be speaking about managing technical debt. And here you go. I will turn it over to Steve. Are you ready?
I'm ready. Thank you for that introduction. Today we get to talk about a relatively new topic, technical debt, but I think while the name is new, the phenomenon it describes is certainly familiar to lots and lots of software developers. Let's see. I guess we should first define our terms. Technical debt refers to a design or construction approach that's expedient in the short term, but that increases complexity normally and is more costly in the long term. And I think there are several reasons to discuss technical debt. One reason is that it helps to educate the technical staff about how business makes decisions. Related and just important reason is that it helps to educate the business staff about some of the business implications of technical decision making. It also raises awareness of an issue and understanding of an issue that's often buried in deep technical considerations, but the benefits from being exposed at a little bit more conspicuous level. It also allows technical debt to be managed more explicitly once we throw it out on the table and look at it and talk about it. I think the analogy comparing technical, suboptimal technical work to financial debt, that analogy is quite rich and ends up producing a lot of insightful parallels. We can extend the metaphor very far and still find benefit in it. And so that's what we want to talk about today. So what I want to accomplish during this talk is I'd like to introduce the technical debt concept in a bit more detail. I want an idea of what's possible once you start really making use of this concept. And I also want to give an idea that what we talk about during the next hour or so is really just the tip of the iceberg. I think that there's a lot more that can be done with this concept once we understand the concept and start actually applying it. So here's what I'd like to cover this morning. I want to describe some common debt scenarios, which is basically a debt primer. And actually, I've collapsed those two sections, so we're going to talk about really just a debt primer. Get into some ins and outs of the technical debt analogy, talk about how you decide to take on debt, talk about how you track debt once you've taken on, talk about how you decide when and how to pay down the debt, and then summarize by summarizing what we can do with technical debt. So turning then to that debt primer, let's look at some of the reasons to take on technical debt and some of the reasons not to. And it's more complicated than this or more elaborate than this, but this is the top level view. Typical reasons that project teams or companies will take on debt is first because they think they can shorten time to market by doing expedient work now, even if it costs more to fix it or make it right later. Sometimes it's a matter of preserving startup capital, where a startup enterprise will have a small amount of money now and will anticipate having more money later. And getting to the point where they're actually generating revenue is really important. And so taking some shortcuts actually makes a lot of business sense. And a final reason is delaying development expense. There are often cases where $1 now and $1 tomorrow are not worth the same amount of money, or at least they don't represent the same level of cost to the business, and so delaying expense can actually make a lot of sense in some cases. So these are sort of the top-level generic reasons that companies take on technical debt. Now, having said that, there are also some reasons not to take on technical debt, and in particular, the reason that many technical staff are all too familiar with is that debt can create a vicious circle. You start out being behind schedule, and so in order to make your schedule, you take on debt. As you take on debt, that debt, due to the definition of debt, reduces your productivity. That reduced productivity leads to less time for new features, which puts you even further behind schedule. And so that circle continues and just gets worse over time. So that, I think, gives you a little bit of an abstract view of what debt looks like, or technical debt looks like. Let's look at some specific examples to really put that picture into clearer focus. Example of bad debt. Guys, we don't have time to dot every I and cross every T on this release. Just get the code done. It doesn't have to be perfect. We'll fix it after we release. I think that's a pretty common end of development cycle dynamic. Sometimes this produces the desired effect, and sometimes it doesn't. What it's guaranteed to produce, though, is a legacy of poor quality code that is either going to have to take time to get fixed later, or is going to be a drag on the project until it does get fixed. Okay, here's a better example, or example that's a little bit more favorable. We don't have time to reconcile these two databases before we ship, so we'll write some glue code that keeps them synchronized for now and reconcile them after we ship. I like this as a good debt example because it identifies a specific shortcut, and it also implies a plan for recovering from that shortcut. So I think that's quite different from the first example. Okay, another example of good debt. Our 6-month-old system was, or rather, our old system was crumbling, so we took on a 6-month refactoring or re-architecture project. After 6 months of work, we weren't able to converge a release, so we had to back out a lot of the work that we had done. The system we have now is a Frankenstein's monster that is buggier than the old system we were trying to replace. And I think this is a case of good intentions but maybe bad execution. We certainly have seen this in our consulting practice a lot, where project teams will take on a fairly large-scale re-architecture or refactoring project, certainly with the best of intentions, but without a really clear business focus. That tends to create more debt than it pays off, and I think this is actually pretty representative of what we have seen over the years. Our final example of good debt is suppose you're on a project team and we say there's a right way and a wrong way to fully support the next version of Android. The right way will cost us 100 staff months now. The wrong way will cost us 10 staff months now, plus 2 staff months in added production support for every month the system is in production. Since we're planning to completely replace the system in 18 months, lifetime cost of the wrong way, or quote wrong way, is 46 staff months, which is cheaper and quicker than the 100-month approach. So in this case, the quote wrong way actually turns out to be the better option. I think this is actually a good example because we're making a very conscious decision, well aware of what the upside is and what the downside is, and we're taking on those costs very consciously, and we end up making the decision on essentially a business basis of saying it's a smaller investment and do it this way, and since the system's going to be retired anyway, it doesn't make sense to invest more heavily. So this would be in the camp that I would describe as overall a good example. Now, for your reference, I'm not going to talk about these now, but if you want to review the slides after the talk, there are all kinds of other examples we could give of technical debt. At the code level, it could include things like violations of coding standards or creating duplications in the code. Style drift, the idea that coding standards tend to change over time in long-lived code bases. Certainly we can have technical debt issues at the design level where we don't have a coherent design or we have inconsistent design approaches. At the testing level, too, we can have brittle test suites or incomplete test coverage. So there are a lot of different ways that technical debt can arise on a project. Let's talk a little bit about, continuing with our primer on technical debt, let's talk a little bit about different sizes and frequencies of debt. We can have technical debt that's analogous to consumer debt. That is something like credit card spending, where if you're using credit cards in an unhealthy way, you're using them on a day-to-day basis to pay for day-to-day living expenses, but you're not paying it off at the end of every month, and that just accumulates debt over time, in many cases with a high and burdensome interest rate. A healthier use of short-term debt like consumer debt would be just for convenience, where you have the discipline to pay off the debt at the end of every month. That could actually be a positive instead of a negative. So the term of the debt doesn't necessarily affect whether the debt is a good thing or a bad thing. We could also have less frequently incurred debt, such as major purchase debt. An example here would be a car loan. And the idea here behind the debt is that if we have to pay for the car all at once, it's basically that would be a misalignment of the cost of paying for the item versus the usage of the item. If we're going to drive that car for 5 years and we take on a loan that we pay off over 5 years, then we're basically matching our payment, the time of our payment for the item, to our consumption of the item. And that can actually make a lot of sense. We want to smooth out our cash flow and have it match our use of the asset, and so that actually can work fine. Finally, we have asset-related debt. That's like a home mortgage, something that we expect to appreciate over time in normal circumstances anyway. And this is also a case where we want to try to use debt to match our cash flow over a period of time to our consumption of the item over a period of time. And sometimes, not always, but sometimes this is based on a bet that our personal income will increase in the future. Sometimes people will take on a home mortgage that's tough for them to carry at the time, but they believe that their income is going to increase, and so that mortgage that seems so burdensome now won't seem so burdensome 10 years from now. I'm sure a lot of us have parents or grandparents who bought their house 20 years ago, and their current house payments are, $79 a month or something ridiculous like that, and that probably seemed like all the money in the world to them when they took on that mortgage 20 or 30 years ago, but now it really literally seems like nothing. And that's basically what we try to accomplish with technical debt sometimes too, is take on debt at a time when spending more money now seems like an awful lot of money to spend, with the expectation that it won't seem like as much later on. So we've, I think, just to talk about the fact that the frequencies really can be broken into two categories. Short-term debt, then, we normally take on with the expectation that we're going to repay the debt in the short term, and usually taken on to cover temporary issues like if we're a business and we need to make payroll and we've done a lot of work and we're expecting payments from our clients, that means we've got receivables. We can take on a short-term financing to cover that gap between when we receive payment for the work we've done versus when we need to make payroll. Long-term debt we use to finance longer-term investments, and there's usually some expectation that we've got a strategic reason for taking on that longer-term debt. So we might be taking on longer-term debt to finance a major purchase like a new manufacturing plant, or to finance a major initiative such as development of the next generation of video drivers. We expect the payoff of those, say, next-generation video drivers to be received over a period of years, and again, it makes sense to match our cash flow in paying the development of those with the return that we expect to get over time, or it can make sense. So, why would we take on debt then? Let's put a little bit more meat on the reasons that I gave at the beginning of the talk. The reasons that companies take on debt, at least the rational reasons, are usually related to some combination of expected value, and opportunity cost. Expected value is a concept from statistics that is simply the probability of an amount occurring times the amount. So, for example, I'm in Washington State in Bellevue near Seattle, and we have a state lottery called Lotto. The odds of winning the game called Lotto are 1 in 27,000. That is a 0.003% chance of winning $1,000 for every $1 play. The expected value of one play is $1,000 times 0.003%. It's actually 0.0037%. But anyway, the expected value of one play is about 3.7 cents. What that means is I shouldn't spend more than 3 cents on any given play. If I spend 4 cents, I expect, in the statistical sense, I expect to lose money. And so in software, the expected value, that is the expected cost of doing a particular task, is a lot lower in the future if I only might do it sometime in the future than if I'm actually doing it right now, because we have to discount it by the probability of actually doing it. So if I'm going to take on a task and I know I'm going to do it today, then I'm paying 100% of it. If there's only a 50% chance I'll take on that task at some point in the future, then the expected value is only 50% of the cost. And so that gives us a reason, that gives us the concept of expected value. Present value is also a relevant concept, and this is based on the idea of, would you rather have $100 today or $100 in 2 years? Most people would rather have that $100 today. And the idea there is that a dollar today tends to be worth more than a dollar in the future. Now, similarly, would you rather pay $100 today or $100 in 2 years? Well, we'd probably rather pay the $100 in 2 years rather than paying it today for the same reason. We expect that dollar to be worth more now than it is later, And so we'd rather get the money sooner and we'd rather give the money later, all other things being equal. And so software projects, when we calculate present value, we also have to talk about opportunity cost and expected value and some other factors. Opportunity cost then is the final reason, and opportunity cost is basically what else could I be doing with this money or resource if I wasn't doing this thing with it. So what is the cost of foregoing these other opportunities I might have? And so the expected value of the other things that you could be doing with that money or that resource is the opportunity cost. And this really is the key concept in time-sensitive markets, like when you need to get a software capability to market quickly, or you're trying to minimize the cost incurred during a startup phase, is that a dollar you spend now is really not the same as a dollar later, especially if that dollar you spend now delays your project in such a way that it might cause you to lose $10 or $100 or $1,000 in revenue because you get the software out later rather than sooner. And so sometimes technical staff will think their businesses are irrational because they are willing to save $1 now even if it costs $5 in additional maintenance later. Well, that's not necessarily irrational. If that dollar you save now opens up $10 in revenue rather than $1 in revenue, then even if you do have to pay $5 in increased maintenance costs later, that's still a good decision because you're still ahead $5 because of the extra revenue you got, and so that needs to be taken into consideration too. So in terms of the reasons we take on technical debt, the most common reason, I think, clearly is opportunity cost, because this idea of shortening time to market, preserving startup capital, or just delaying development expense. Now, this really brings us to a discussion of different categories of technical debt, and this, I think, is important because some of the categories are much more desirable than others. We have unintentional debt, and that's the debt that we incur due to low-quality work. And this really can be divided into two kinds. Honest mistakes, such as, I wish we'd known Framework 2.1 would be so much better than Framework 2.0. Oh, you didn't know. There was no way that you could have known. It's an honest mistake. It doesn't change the fact that you actually incur some debt because of developing on that lesser framework. But then there are also careless mistakes, like design. What design? Design is for sissies. Well, that's not an honest mistake. That's a mistake that you make through sloppy practices, and so you can get unintentional debt that way as well. I think we want to avoid unintentional debt, period. Some of it's easier to avoid than others. The honest mistakes are hard to avoid, but the ideal here is to avoid unintentional debt. Intentional debt is debt that we incur on purpose, and this, I think, is useful to break down into short-term debt and long-term debt. And short-term debt we usually take on reactively for tactical reasons. Typically in order to support getting a particular release out the door in a particular time frame. And I think in short-term debt it's useful to differentiate between focused short-term debt, which are individually identifiable shortcuts. That is, per the earlier example, we're not going to try to reconcile these two databases before we ship. We'll reconcile them after we ship. And I think those are acceptable because we can identify them, we can put them into a product backlog or into a defect log, and we can get them on the list so that we know what they are and we can fix them at a later time. Now, in contrast, unfocused short-term debt is what happens when somebody says things like the other example I gave earlier, which is, guys, we don't have time to dot every I and cross every T, just get this thing out the door. Well, that leads to taking numerous tiny shortcuts that are untracked, and those are almost impossible to go back and fix after the fact because we don't even know where all of them are. And fixing those is tantamount really to doing the project over, and we're rarely going to get permission to do that. Okay, the other kind of intentional debt is long-term debt, and that's usually incurred proactively for strategic reasons such as making invest in one platform versus another or something like that. Out of these kinds of debt, the only kinds I think are really a good idea to take on intentionally anyway are focused short-term debt and long-term debt. And I think that's really it. These other kinds of debt are problematic. They're difficult to track. They're difficult to pay off. They tend to be a drag on the project, and so I don't suggest taking on those other kinds of debt. Well, this brings us to some more detailed ins and outs of the technical debt analogy, and I think these can be instructive as well. One is the concept of debt service. If you have a real financial debt, you're going to have interest that you pay on that debt, and you have to pay that interest above and beyond the principal. That is, in essence, a service charge for being allowed to take on the debt. Now, interest can be structured in different ways. You may have to pay it off periodically. You may have to pay it off all at once when the debt is repaid. But I think in the technical debt context, for something to qualify as debt rather than just a design trade-off, there has to be some kind of interest. There has to be interest that's paid on an ongoing basis. There has to be interest that's paid all at the end. But if there's not some notion of an extra payment above and beyond just doing the work a good way the first time, then it's not really debt. It's something else. So here's an example. Is this technical debt? Quote, we don't think we're going to need to support a second platform for at least 3 years. So this release can be built on the assumption that we're supporting only one platform. If we need to support a second platform, we'll do the work later. Well, this example of delayed work, to be sure, but I don't think that all delayed work is debt. I think this is just a case of sequencing the work, and unless it creates extra work to do it that way, then I don't think we can characterize that as debt. I have in a feature backlog, features that we've deferred, features that we have cut in order to make a release. These are not necessarily debt. It comes back to this question of, is there an interest payment? And if not, then it isn't really debt. Now, another concept that's interesting to apply to technical debt is what's called the debt service coverage ratio, or DSCR. And in finance, this is a specific common measure of financial health. And in software, the analogy to DSCR is really the ratio of work that you spend on advancing the software versus the work that's needed to keep the software from sliding backwards. And so an example of that might be something like this. Quote, we have a legacy code base that's 10 years old. Out of our $3 million IT budget, we spend about 50% just making the changes necessary to keep the production system running. So there, the DSCR is pretty high because we're spending half of our budget basically just treading water, keeping the system from going backwards. And so that's something we should probably think about. Is that a healthy level, or is there something we could do to pay down the debt so that the debt service coverage ratio isn't so burdensome? Credit rating is another interesting concept to apply to technical debt. In financial terms, credit rating tells you what borrowing power different consumers or businesses are going to have. A good credit rating gets you higher borrowing power. Well, I think in software, teams truly have different abilities to carry technical debt responsibly too. And if you have a team that's carrying a lot of debt due to low quality work, unintentional debt in other words, they will have less ability to take on intentional debt for strategic reasons than a team that has been more conscientious about keeping its unintentional debt low in the first place. And so this is one of the interesting points about technical debt, I think, is that we really want to minimize the debt we take on unintentionally so that we create the option to take on debt intentionally when it makes sense to the business for us to do that. Acquired debt, I think, is another relevant concept. We can have, it's not our fault, debt that was taken on for strategic reasons perhaps, but we weren't there making the decisions. Somebody else make the decisions, and we have to live with the consequences. You know, maybe you've bought into that debt, maybe you wouldn't. Sometimes I think we see this very commonly occur when one company acquires another company and they try to work with the acquired company's code base. You can actually acquire debt from that other company as part of what you get in an acquisition. Another relevant concept is 90 days, same as cash. Sometimes this is an option. That is to say, sometimes if you pay the debt off quickly enough, there's no real interest payment. So if you wait longer, there might be an interest payment, but if you pay it off quickly, there's not. And so the notion that a team is cranking toward a release, they take some specific identifiable shortcuts to get to the release, and then immediately following the release, they do that work and clean up the shortcuts. There might not be any extra payment on that. So whereas maybe if they wait a year, maybe it would cost more to get that same work done, but right after the release, maybe it's not any more work. So 90 days since cash really is, I think, a relevant concept. monthly payments is another relevant concept. And I think one of the things we ought to think about when we take on technical debt is what is the threshold level of activity needed to make a minimum payment. Is the threshold activity really low, like we roll up a new version on the website? Is it high, where we have some hard costs, like sending out DVDs? Or is it high still, like we have to replace chips in a computer or replace a box on an airplane? Well, the ability to pay off debt depends in part on what the minimum payment is. And if we have even a tiny error, one that's easy to fix, it only takes a few hours of development time to fix, but it requires us to replace a box on an airplane, well, that's going to be a very different decision than if we have the same kind of defect, or debt rather, that takes a few hours of development time, and we just have to roll a new version up onto the website. Retiring debt is an interesting one. I think that, in my experience, teams normally find working off debt, that is, doing work that reduces technical debt, to be motivating. They feel like they're improving the system, and they get satisfaction later on when they work in that system that has experienced those improvements, and they get to work in a more satisfying way. Now, a special case here where we actually get a break in the analogy between technical debt and financial debt, and that is at the end of a lifetime of a system, or end of service. When we retire a software system, unlike financial debt, all the technical debt retires with it. And for this reason, as we get a system that approaches the end of its life, cost justifying anything other than the most expedient solutions becomes increasingly difficult. If we know a system is going to be discarded 3 months from now, there's just no financial benefit to doing anything other than the cheapest thing that will keep it glued together for the next 3 months. Now, if that system is going to live for the next 5 years, calculation is different. But when retirement is imminent, that changes our decision making, or at least it should change our decision making about the permanence and quality and integrity of all the changes that we're making. The decision to take on technical debt is one that I think should be made deliberately. Here, what we usually find when we decide to take on technical debt is that we're comparing a trade-off between some good solution and some quick and dirty solution. Implicitly, when we decide to do a quick and dirty solution rather than a good solution, we are assuming that the quick and dirty solution is actually, in fact, quick compared to the good solution. And I think it's valuable to get those assumptions out and make them explicit rather than just having them locked in somebody's brain. So let's say, in this example, that we've decided that the cost of a good solution is 10 staff days. And so if we assume, I'm just going to assume for purposes of illustration, a cost of $600 per staff day. So this option is guaranteed to cost us $6,000 now. So that's the cost of the good solution. Option number 2, the quick and dirty solution, we've estimated will only cost us 2 staff days for the immediate work. And then the interest payments we expect will cost us 1 to 3 staff days until we get to the point where we implement the good solution. And in this case, the deferred cost to retrofit the good solution is actually higher than the cost to do it initially, in part because we have to rip out the bad solution. And so the total cost here ends up being 15 to 18 staff days. And so, but the cost now is only $1,200 instead of $6,000. The cost later, when we get to the point of doing the deferred solution, will be $7,800 to $9,000, and our total cost will be basically $9,000 to $10,000. So certainly higher than the $6,000 of doing the good option now. Now we could stop here, and in my experience, most developers and project teams do stop at this point, and they make a decision like, well, can we afford to spend the $6,000 now? If we don't spend the $6,000 now and we have to pay the $1,200 now, is it really going to be worth it to pay the extra later? And that's pretty much the extent of the analysis. The point I would make here, though, is that often there is another option, and what we should look for is an option that might be construed as quick and dirty, but that doesn't incur any interest payment. So there's no real cost of not fixing it as we go. It's just that there might be a cost of retrofitting the good fix later, but no ongoing costs that we incur as we go. So let's say here that the cost of a quick and dirty solution, which is slightly better than option 2, in that it doesn't incur an ongoing interest payment, is $1,800, and then the cost to retrofit it is still 12 staff days, just like option 2, and so total cost would be higher, $9,000, than the cost of doing it the good way first. But the key point here is that with the cost now of $1,800 and no ongoing interest payment, we don't actually have to retrofit the good solution. We can wait indefinitely if there's no ongoing interest payment for that. And that's really a big difference between option 2 and option 3. Option 2, because there's an ongoing interest payment or cost incurred, we're paying day by day, week by week, month by month for not implementing the good solution. With option 3, we're not making that payment. It just costs us more when we get to the point that we decide to do the good solution, but not until then. And I think often the best decision is option 3, but we often don't do the work to come up with that. And I think this often comes down to basically how creative can people get about the design. And we may have to think a little bit harder to come up with a good design alternative that will support a quick and dirty solution, but that does not have an ongoing interest payment. So the key point here is really to avoid binary debt, no debt decisions. I think we usually have way more options available than that, and if we can really focus on zero interest options and give ourselves the opportunity to never pay off the debt, possibly, then we really want to do that. I think in general we should ask a number of key questions. We should ask, do we have estimates for the debt and non-debt options? If we don't, why are we even talking about taking on debt, right? We shouldn't be talking about taking on debt unless we have some quantitative notion that there's a benefit now to taking on that debt. The question we should also ask is, do we believe the estimates? Well, if we don't believe them, why are we taking on the debt? And then, of course, we'd ask, how much do we reduce our effort now by taking on this specific technical debt? How much will the quick and dirty option cost now? How much will the clean option cost now? And how much will it cost later to replace the quick and dirty option with the clean option? Those are key points in the decision. Also, we should be asking, what will the interest payment on the quick and dirty option be? We should ask how that interest payment is structured. That is, do we have to pay it on an ongoing basis, or do we only have to pay it off all at the end? If we only have to pay it off all at the end, maybe we structure the project in such a way that that debt just gets retired when the system gets retired. We should at least ask the question, are there issues involved in paying back the debt, such as replacing the box on the airplane? Why do we believe it's better to incur the effort later than to incur it now? What's going to be different in the future than it is now that makes it more palatable to pay it off later than it is now? If startup mode and cash is king and we really have to preserve cash at all costs, well, we know it's going to be different later. If we're just in a normal business operation where we're in a mature business with a mature software system and we're on release 7 and we're going to be going into release 8 and then release 9, it's hard to make the argument, I think, that dollar later is going to be any different than the dollar today. Can we track this specific debt? That's important because we need to be able to down the debt. We have to be able to know where the debt is, and so tracking it is important. Considered all the options, including any zero interest options. And then here's a key point that many technical staff have been burned by over the years. Who in the business is going to own the debt? He needs to take responsibility for the decision of taking on the shortcut now and owning the business value of that decision, the business value that says this is worth more now, even if we are worth enough now that even if we have to pay more later, it's a good decision. And that ultimately is a business decision more than a technical decision, I think. The technical job is to really inform the business about what the trade-offs are, but then the business's job is to make the decision about the cost of the dollars now versus later. It also brings up the question of how much debt is enough or too much. I don't think there's any one right answer, just like there's no one right answer for financial debt. Technical staff's attitude, in my experience, tends to be a little extreme. A lot of technical staff will say the only right amount of debt is zero debt. I don't think that's right any more than that's true for financial debt. Business staff tends to have a higher tolerance for technical debt, but as many of us have experienced, they also tend to have a shorter memory for the fact that we took on the debt, and we may have to put some structures in place to help the business remember the debt that it's decided to take on. And that's just part of the challenge of technical debt. I'd like to turn now to the topic of tracking debt, and I believe that all good debt can be tracked. By definition, any debt that we intend to take on, we should be able to identify individually, put into a product backlog or a bug list, and track it in those ways. We've seen some companies track debt by defects. We've seen other companies track them in product backlogs. And in terms of measuring the effect on the project, we've seen some companies that monitor project velocity, and they'll say once our velocity drops below a certain level on a per iteration basis, we'll make the assumption that the debt is getting to be too burdensome, and so schedule an iteration to do some debt reduction. And other companies will monitor the amount of rework and simply track the amount of rework they're doing and use that as an indicator of the technical debt. We can certainly add up the total debt in a product backlog as one measure of debt. Some companies will look at their maintenance budgets or take some fraction of their maintenance budget and use that as a proxy for the debt they take on. We have one client that basically says we look at the backlog of customer-facing work, and we age that in the aged receivable sense. And when we get anything that is aged beyond 180 days, that automatically goes to SEV 1 and becomes a top priority to fix. Even if it started out as a SEV 2 or 3 or 4 defect, once it gets to 180 days, because we don't want this debt to accumulate indefinitely, they just escalate it to SEV 1. I think it's useful to measure debt in money rather than features, just in terms of communicating with the business. If we can say 50% of the or something like 50% of the R&D budget is non-productive maintenance work, that really hits home at the business level because it's couched in terms the business actually understands. The decision to pay down technical debt is one that's important as well. And I think good reasons for paying down technical debt are normally based on business need or business benefit. Bad reasons, and I don't really mean bad in any moralistic sense, I mean ineffective, that is reasons the business people won't accept, tend to be very technical sounding. And so examples of this are, a good example would be a scenario where we want to pay off short-term debt. We might make a statement like, we took some shortcuts to get the last release out the door, and now we need to clean up the code before we start writing new functionality. Okay, I think that's a reasonable scenario for paying down debt. Another example of a good reason to pay down debt might be debt service. Maybe we're incurring longer release cycles that are undermining business operations because of the interest payment on the technical debt. And if we can go to the business and say, we'll be able to get future releases out in 5 months instead of 6, if we can spend some amount of time right now reducing our debt, that's a rationale that is couched in business terms that a lot of businesses are going to be receptive to. Another good reason, debt itself in the form of low quality is undermining business operations. So the example might be something like, some of the, quote, shortcuts we've been taking have started to become visible to the customer, and the number of customer-reported defects has been increasing. And pay down our debt, we will have an increasingly difficult time assuring quality prior to release. Again, this is talking to the business in terms the business understands, basically quality. That can be compelling to the business. Another reason, another good example, the final good example I'll give you to pay down debt is debt in the form of a technical limitation is preventing access to new business opportunities. So the example here might be, if we spend X number of weeks working on technical infrastructure in area Y, we'll be able to add features A, B, and C, which we can't add now because of shortcuts we took when we originally implemented area Y. And so again, this is couching in business in terms the business understands that there's a capability that the business wants or the customer wants, that is features A, B, and C, that we can add because our work in area Y is blocking that. And I think this is kind of rationale that businesses tend to be pretty receptive to. Now, some things to avoid in giving reasons for paying down technical debt are technical sounding terms. I think businesses are rarely motivated by terms like saying the design is bad or old or crusty or not object-oriented or not agile. Those are not business terms, and the business is typically not going to see the business value in having a design that is not, quote, crufty or not, quote, agile. And so I think the more we can tie the justification to business benefit, I think the better success we're going to have in convincing the business that we we need to do it. I also think that we don't have to justify every single initiative in paying down technical debt one by one to the business. We can just plan in some debt reduction as part of our normal workflow and part of doing a good job. That is to say, if we're doing, say, monthly iterations, let's say that we're in an agile context, we're doing, I'll just make up a number here, we're doing 50 story points per iteration. We might just say we are going to pay down, let's say, 3 to 5 story points worth of technical debt iteration. So we just build that into our normal iterative development process and have some fraction of the work, maybe it's 5, 10, 15%, 20%, that just goes into paying down debt. And that does not have to be visible to the business. If it becomes visible to the business, it's easily defensible. That is, this is part of doing a good job, is maintaining the quality of the thing we're working on. It's like we don't have to rationalize taking our car in for scheduled maintenance. Likewise, we shouldn't have to rationalize some fraction of our efforts going into keeping the system operating at an effective level. So what are some approaches to actually paying down technical debt? We've seen a number of approaches with the companies we've worked with. You can certainly do a debt reduction iteration immediately following a full product release, especially if you've taken on conscious short-term debt through individually identifiable shortcuts. That is a very rational way to do that. It's timely. The team tends to find it satisfying to have a chance to go back and immediately clean up the work that it probably at some level resented doing in a slipshod way in the first place. And also it tends to be a time when teams could benefit from a little bit of a pause and before they jump right into the next release. So a debt reduction cycle can make a lot of sense, a debt reduction iteration. I just talked a moment ago about amortizing small debt payments into each iteration. I think that makes sense. I do think that it makes sense to require that above a certain threshold, one of our clients uses a threshold of 250 hours, that debt reduction initiatives need to be approved as separate projects. In our experience, large debt reduction initiatives don't tend to produce the intended results. They tend to end up being relatively unfocused refactoring initiatives or architectural improvement initiatives. And the Frankenstein system example I gave at the beginning of the talk is, in our experience, a pretty common outcome of those initiatives, that without a clear business objective on the table to focus the debt reduction work, the work tends to be unfocused. It tends to move the systems in system directions that aren't in fact valuable to the business. And so we've learned through the number of companies we've observed to be really, really cautious about large debt reduction initiatives that don't also have some increment of business functionality as part of the initiative. We've also seen cases where individuals will rotate through debt reduction duty. I think that in general, it's good practice to make the individuals that incurred the debt also be the same individuals that fix the debt. It's efficient to do that. It's also a good feedback loop for the individuals, but that's not necessarily how it has to work. Some organizations will view that work as being less desirable, and so they'll have individuals rotate through on a month at a time or iteration at a time or a couple iterations at a time or something like that. And finally, the other possibilities that offshore resources can be used to reduce debt. The nature of debt reduction work is often different in some ways than the nature of doing new development work, and in some cases it might be hard to cost justify doing debt reduction work with onshore resources, but if you can possibly assign some of that debt reduction work to lower cost offshore resources, sometimes you can justify doing debt reduction work that you couldn't otherwise justify doing, or you'd have a harder time justifying doing. Well, that's been a pretty quick tour of the technical debt universe, and so in summary, what can we do with technical debt? We can do a lot of things with it. We can talk with technical staff about it. We can communicate to business staff the implications of debt, and I personally have found that business staff tends to be highly receptive to this concept. It makes sense to them and they get it. We can measure the amount of debt by identifying the concept of technical debt. It gives us a way to think about it. We can make explicit decisions about whether we should take on more of the debt. We can get input from the business about whether the business believes we should have more debt or less debt and what impact on the business that debt is having. We can strategize how to avoid debt, we can track the debt, and we can make explicit decisions about when and how to reduce the debt. And I think all of these are good reasons to talk about technical debt. So with that, I am going to hand back the microphone, so to speak, to my colleague and open the floor for questions.
Thanks a lot, Steve. We've got a number of questions here. We're going to start off with Darren Mitchell asks, abstract, it sounds easy to estimate the interest payments, but in life, isn't it harder to estimate the ongoing costs of the shortcut now as opposed to the cost of development, which we may tend to underestimate, but at least we have experience with?
So I think this is really the key, one of the absolutely crux issues of technical debt, and that objection is exactly right. Isn't it hard to estimate the cost of the different options? Well, the key point here is to understand that when we make a decision, consciously or unconsciously, to take on debt, we are at least implicitly estimating the cost savings from taking on the debt now. If we weren't estimating cost savings at some level, we wouldn't be taking on the debt, period. And so I am arguing, since we are making those estimates implicitly when we take on debt, we shine a bright light on those estimates and we should make them explicitly. And in fact, we are not in a good position to make those estimates, then we shouldn't be taking on the technical debt because the benefit really isn't that clear. That is to say, the near-term benefit of taking on the debt isn't that clear if our estimates aren't very clear. So I think that's an excellent question, and it is perfectly fine to get into a situation and say our estimates aren't clear in this case, the savings are unclear, and therefore we're going to pursue the good solid approach rather than the shortcut approach because the savings really, we know what the savings are. I think that's a perfect outcome of that.
All right, we'll move on to the next question here from Jose Rodriguez. How would software development and testing in the cloud impact the technical debt management strategy in an organization?
How would software testing in the cloud impact the technical debt management in an organization? I'm not sure that I see a direct connection there. The nature of technical debt is typically the shortcut that's taken is an internal shortcut that is not visible to the end user or visible through black box testing. That is, through testing by people who don't know exactly how the code works. So it's not something I'd really thought of before, but at first glance anyway, I don't really see any way that testing in the cloud would change the technical debt calculation.
Right. Our next question is, does agile programming make it easier to avoid debt or get out of debt?
I think agile programming helps in a couple of different ways. One is, through the focus on short iterations, it makes it easier to add small debt reduction initiatives into these short iterations. If I've got a development cycle that's a year or 2 years long, and I accumulate a bunch of debt as I get to the end of one of those 1 to 2 year long release cycles, then if I pay off the debt, I'm probably doing it in the context of another 1 to 2 year long release cycle. And that can introduce a lot of lag time between when the debt is incurred and when the debt is actually paid off. If the debt tracking is not really excellent, then a lot of that debt can just fall through the cracks. We can literally forget what debt we took on. And so I think the discipline of short iterations makes it easier to track the debt for a short time and then pay it off more quickly. And so I think in terms of getting out of debt, I think the agile programming does help. In terms of avoiding debt in the first place, it kind of depends on how you define the word agile. But if part of what you mean by agile is the discipline of keeping the software pretty close to a potentially releasable level of quality at all times, then and you're on short iterations of a month or shorter, then I think that discipline of keeping the software quality high does help, particularly in avoiding the unintentional debt, which is, I think, the most damaging kind, because you're not sure where it is. And if you don't get into that unintentional debt situation in the first place, because of that discipline, yeah, I think that's a huge plus.
All right. Next question is from Tom Willikes. I hope I pronounced that properly. Is gold plating a form of technical debt? An example, he says, is designed for anticipated requirements that never materialize, complicating the design and implementation.
Well, interesting question. I would go back to my litmus test of, is there an interest payment of some kind as a result of that gold plating? I think there are other reasons to avoid gold plating. I think gold plating in general tends to guess incorrectly about the future requirements that are as yet unspecified. It adds complexity to the code, which I think is just inherently increases the risk in the code. People don't tend to put the same level of care into the gold plating work that they put into the main work, and so it tends to be buggier and cause some defect correction work. So I think the tendency with gold plating probably would be to increase the interest payment and therefore the debt. You have to look at specifics of any given case to say, does this actually qualify as technical debt? But yeah, I think that technical debt would be, or the potential for technical debt would actually be a good additional reason to avoid gold plating.
All right, our next question comes from Wally Lawless, who asks, where would you start in a situation where you don't know how much technical debt you already have or how much it's costing you in terms of time?
Yeah, interesting question. I think usually you're not even going to start talking about technical debt unless the development team has at least some subjective feeling that poor quality is slowing them down. And so in those cases, I think the trick is, and the team agrees that the debt is slowing them down, then the trick really is quantifying it. I don't think there's any good general, well, let me back up a minute and say, I think the question sort of implies that an entire situation, like an entire code base, and they're going to take some kind of action against that entire situation or entire code base. I think in these situations what probably works best is to keep the debt reduction focused on current work. That is to say, I got some capability enhancement I need to do, and so if I have a capability enhancement I need to do, is there technical debt that I can see direct line of sight as I'm adding this capability? And if so, I'll reduce that technical debt that I can see, but I won't worry about the rest of the technical debt that I'd actually have to go looking for. So I kind of think of this as like backcountry hiking or backcountry camping, where the rule is if you get in, you pack it out, and the other rule is you take an extra bag so that if you find stuff that you actually that other people have left, you put their stuff in your bag and you take that out with you too. I think that can be a good discipline for a team that's working on a legacy code base, which is, first, don't leave it any worse than you found it, and second, if there's something that's directly in your path that you can improve as you go, then go ahead and do that too.
Okay. Our next question is, how do you pay off technical debt if you're in a maintenance environment and don't have the budget or resources you need to pay down debt?
Well, I think that this discussion is in a maintenance environment. I think the vast majority of software that people work on is not version 1. It's some version later than version 1. So I think that's where most of the conversation does have to occur. I think that if your organization views your department as a maintenance department, then what I've seen work the best is really just allocating a fraction of time to debt reduction work. And it's essentially like keeping your work area clean in a shop environment. That's kind of what we're doing in a technical sense. And a number like 20%, some number like that, I think is a ratio that I've seen work at a couple of companies. And we don't really try to justify the debt reduction case by case in those environments. We just sort of assume that something on the order of a couple hours a day or on the order of 1 day a week is going to go into fixing stuff that maybe isn't causing any current identifiable misbehavior in the system, but that has the potential to cause problems.
Just for a few more questions here before the top of the hour, and the next question is, what's the difference between debt and just a bad design decision?
Well, I do think that they can tend to overlap to some degree, and I guess I again go back to my litmus test of the interest payment. I have never worked on a project where at the end of the project, everybody on the team sits around and looks at each other and says, wow, this came out perfectly. We made every decision right, and if we had it to do over again, we would do it exactly the same way. I have never seen that kind of a project. The act of going through software development causes us to learn things about how we developed that system. And in cases I've been involved in, by the time you get to the end of the system, you usually have a long list of things that knowing what you know now, you wish you'd done differently. So when we say something was a bad design decision, I think in hindsight an awful lot of decisions are bad design decisions. If by that we mean we could have had a better design decision. But we do the best we can at the time we make those decisions. So what's the difference between debt and a suboptimal design decision or a design decision we wish we'd made differently? I think it really comes down to, are you paying any cost on an ongoing basis as a result of that suboptimal design decision? And if you are, then you have to try to put your finger on how much is that extra cost and what would you really save if you could implement a different design decision. If it turns out that cost is ongoing and it's significant and you could save it by implementing a different design decision, then yeah, I would count that as technical debt.
Right. I believe this is going to be our last question. The question is, debt is ever completely avoidable, or is it just a fact of life we have to learn to deal with?
Yeah, that's a good question. I don't think it's ever completely avoidable. I think our goal really is I think the biggest goal we have is avoid the debt that we accumulate through consciously doing quick and dirty work. The rush mode that teams tend to get into toward the ends of release cycles where they say, we don't have time to do this right, we've just got to kick it out the door. That's the debt I think that accumulates the most damagingly. And so if we can avoid just doing that, part of the problem with that debt is I think that it's harmful in the long term, but it's questionable whether it's even beneficial in the short term. And so I think if we can avoid that kind of debt, it's unclear to me that there's any short-term penalty for that, but there definitely would be a benefit in long-term maintainability of the system, understandability of the system, and support for future work. So that would be what I would try to do, avoid that hundreds of shortcuts kind of debt, and then just do the best we can on everything else, realizing that it's not going to be perfect, but we'll do the best we can.
I think that's the end of the webinar there, Steve. We seem to have covered all grounds.
All right, thank you, Alex.
Thank you very much for taking it to Steve. If you folks out there can't get enough of Steve's presentation, the slides and the rest of the recording from this will be up within 24 to 48 hours, and you can always find Steve's books on Amazon and all sorts of wonderful book sites on the internet. Thank you for joining us today at ST Times, and thank you for joining us with Construx in a discussion of technical debt. We hope you join us again for the next webinars, and feel free to contact Construx with any further questions. Steve's email is there on the screen for you. Thanks a lot.